Good day. Today we're going to present about the coastal environmental profile of Sitio Linao. The coastal and marine habitats offer a plethora of services necessary for the survival of the human population. However, this overdependence has seen an unprecedented increase in demands for its services, resulting in overexploitation and destruction of natural resources. To elucidate its impacts on a model community, a biodiversity assessment in Sitio Linao Maasim encompassing different ecosystems was performed to provide supplemental information on its current coastal and marine ecosystem conditions. A total of 4 mangrove and seagrass and 15 macrobenthic invertebrate species, 23 phytoplankton genera, and 5 zooplankton order were recorded. Of the four mangrove species, Avicennia marina had the highest relative density with 40.70 and dominance with 31.1, and seagrass community cover was primarily dominated by Enhalus acoroides with 57.27%. Among the macrobenthic invertebrate species identified, Diadema citosum was the most observed, with 38 individuals, followed by Proteroaster nodosus with 26 individuals and unidentified Nerita species with 22 individuals. Phytoplankton assemblages were composed of cyanobacteria with 75.52%, diatoms 24.28%, and dinoflagellates or 0.14%, with Oscillatoria as the most dense phytoplankton group, with 36,925.17 cells per liter. The order Calanoid, Aphragmophora, and Cyclopoid were the most abundant among the zooplankton community. Occurring in the southern part beyond the reef slopes, sea surface currents during flooding tide has an average speed of 17.04 centimeter per second, while ebbing tide has an average speed of 19.78 centimeter per second. Qualitative information on the level of knowledge of the locals about coastal ecosystem conservation revealed that mangrove rehabilitation was the most shared concept, whereas the Department of Environment and Natural Resources was the agency known to provide these programs. The results provide supplemental information on the species occurrence and the current status of the marine and coastal ecosystems in Sitio Linao, suggesting that periodic assessments of these communities should be established to understand the threats affecting these important habitats. Coral reefs, seagrasses, mangroves, macrobenthic invertebrates, and plankton all offer a variety of habitats necessary for the survival of fish, food, and other marine species. These habitats provide critical food and revenue sources such as fisheries and tourists. Additionally, coastal and marine ecosystems are also excellent carbon sinks, making them critical repositories for mitigating the consequences of climate change. But as the population grows, the demand for products and services provided by the coastal and marine ecosystems expands, often resulting in varying degrees of environmental degradation. While ecosystems are naturally capable of recovering from disruptions, widespread neglect and poor management obstruct their recovery. Thus, a sound management strategy is required to halt loss and damage and focused efforts to restore and enable ecosystems to recover. To establish an appropriate, rational, and successful management plan for the Philippines' coastal and marine ecosystems, an accurate and current evaluation of their extent and condition and the threats impacting their status and health are needed. However, despite these growing efforts to record the country's biodiversity, there is a need to update the data on the coral cover, fish assemblages, seagrass cover, and mangrove ecosystems and their associated marine organisms. Hence, a biodiversity assessment was performed to update the condition of the coastal and marine ecosystems in Sitio Linao, Maasim, Sarangani. The findings of this assessment could give valuable information on the status of the ecosystems, thereby helping in the management efforts to conserve the declining health of the biodiversity in the area. The objectives of the biodiversity assessment are the following. First, identify the composition of constituent species. Second, determine the condition of the various coastal and marine ecosystems. Third, provide details on the sea surface water current prevailing in the area. And fourth is to determine the socioeconomic profile and basic knowledge of the residents about the coastal ecosystems of Sitio Linao. Significance of this assessment. This assessment may help in the long-term marine ecosystem monitoring programs of the Protected Area Management Office of the Sarangani Bay Protected Seascape. They may utilize the results to supplement their data about the status of mangrove forests, seagrass beds, macrobenthic invertebrates, coral reefs, and phytoplankton species present in Sitio Linao, ensuring the long-term viability of the marine ecosystems. This information would serve as a guide for further studies on marine biodiversity and ecology. The biodiversity assessment's findings would be a great help and benefit to society such as students, professors, prospective researchers, and the residents of Sitio Linao to better understand the status of the marine and coastal ecosystems. Therefore, this biodiversity assessment is done to observe and learn more about the current status of the marine ecosystems in Sitio Linao, Maasim. For the methods section, the photo presented on the screen depicts the various areas where biodiversity assessments were conducted. The biodiversity assessment site was carried out in Sitio Linao, Maasim, Sarangani Province between March 31 and April 3, 2022. The coastal and marine ecosystems of the assessment stations and its constituent species were evaluated. The light blue represented the mangrove forests, yellow for seagrass and macrobenthic invertebrates, red for the coral reefs and associated fishes, grayish for the sea surface current, and the dark blue for both the phyto and zooplankton. One of the critical components in mobilizing coastal environmental profile is to underpin the importance of citizen science in biodiversity conservation by performing interviews, focus group discussions, and surveys with the residents, which would generate crucial information on the ecosystems thriving in the area. We use the semi-structured interview survey in our coastal environmental profile. Interviews regarding the local socio-economic profile and level of awareness on the coastal and marine ecosystems was conducted. A total of 8 respondents from different backgrounds residing near or within the community was part of the collection information through semi-structured interviews. This is to ensure that the knowledge of the locals was measured using qualitative information to understand the need for further information and education campaigns about these ecosystems and the threats impacting them. To elucidate further their answers, views, or opinions, we used the thematic analysis. Discussions and answers from the open-ended questions asked to selected participant residents were classified and analyzed into themes to identify patterns, which would generate insights and concepts on their knowledge about the marine and coastal ecosystems of Sitio Linao, as well as the threats occurring in the area. Now for the results and discussion, most of the respondents were mothers, married, and had attained education at the elementary level. People in this group are between the ages of 19 and 59. They are all from the same tribe, the Samatausug, and most of their descendants are Muslims or followers of the Islam. Most respondents were involved in fishing activities and their husbands mainly did the work. Their money comes from selling fish they catch with fishing nets called pukot and handline fishing called mamasul. Many of the respondents' family members own the boat or part-time fishers. The fish they catch are then traded, eaten, or sold. An interview with Miss Aika Amina Hussein revealed that fishing had been the main source of income in the village. The transcript translates into, "My father is a full-time fisher. It would take an hour to reach the fishing grounds via a small boat and using fishing nets. In 3 days, he could gain 2,000 pesos. He would only spend one night, then come home the next morning. Sometimes, he could have an income of 3,000 pesos in one night since fish are expensive today. The smallest income we had was only 500 pesos, and that was during windy weather conditions. Similarly, an interview with Mrs. Delfa Bantangan found that though they have income from fishing, these were usually split with the members of the fishing boat. In fishing, we could have an income of 1,500 pesos in one day, but we still need to split the money with the boat owner. We only share 40% of the income, while the 60% goes to the boat owner. Furthermore, Mrs. Fatima Osuri's husband and son are also fishermen working together to provide their daily needs. We own a boat, but my son and husband seldom venture out to the sea to fish using torn out fishing nets. We let others rent our boat. Sometimes we could have an income of 5,600 pesos in fishing, but we have to pay labor amounting to 1,500 pesos. We consume the fish, but sometimes I let my daughter sell them to the people in the resort. Although residents primarily engage with fishing activities for their livelihood, oftentimes their income could not suffice their expenses such as food, loans, clothing, school supplies, and water. Most villagers neither own an insurance like PhilHealth nor beneficiaries of 4Ps. Yet, their food expenses range between 500 pesos and 5,000 pesos. Despite their insufficient source of income, some people tend to engage with loan activities to suffice their needs. A previous worker of local Tibud, Miss Delpha Bantangan, is currently a boneless milkfish worker in a private company in Jansan. Although her husband is engaged with fishing activity, she says that it is not enough to meet their daily needs since food has become expensive these days. We are not four-piece beneficiary, but we are now today. I work in Jensen where I usually remove the bones of milkfish. Despite working together with my husband, we still find food expensive. In one in 1 month, we could spend 5,000 pesos. We only buy clothes when we have spare money. I also buy my maintenance since I have an asthma. As of today, we have been paying a loan. An interview with Mrs. Snifa Jubahani, 28, further confirmed that she had a loan to pay. Her husband has only been a part-time laborer of a small fishing boat in Sitio Linao. Sometimes, her husband works at a construction whenever a position is vacant. The food is expensive. We need to spend 3,000 pesos per month in order to buy food. My husband is only a laborer of a small fishing boat, yet they still have to split the income with the boat owner. Sometimes he applies as a construction worker, but the income is not enough for our other needs. Despite the fact that majority of the population in City Lina have been inhabiting the coast for more than 10 years, it appeared that only coastal cleanups, mangrove rehabilitation, creation of mangrove boardwalk and feeding programs were conducted by government agencies, which were primarily spearheaded by the Department of Environment and Natural Resources and the Philippine National Police. The photo presented on the screen are the government agencies and their corresponding programs for Sitio Linao. So for the Department of Environment and Natural Resources, they do mangrove rehabilitation, coastal cleanup, tree planting activity, mangrove boardwalk. For the Philippine National Police, they also conduct coastal cleanup, tree planting activity, and feeding program, whereas the Barangay Tinoto conducts coastal cleanup and tree planting activity. Mrs. Amang Arasani mentioned that they have been living in the coast for more than 10 years, yet there were no economic programs related to the upliftment of the community. She also shared that only mangrove rehabilitation programs and coastal cleanups have been done related to the marine environment. We have been living here for a long time, but we still have no economic development. Sometimes DNR comes here to plant mangroves and do coastal cleanups. There is a need to do cleanups in the ocean. Meanwhile, Mrs. Norsiva Sanawi also shared that similar programs have been undertaken in the coastal residences. Sometimes the workers of the barangay come here to plant mangroves and do coastal cleanups. Sometimes police officers also come here to plant mangroves and clean the shorelines. Similarly, when asked about their response on the initiatives of these government agencies, Mrs. Fatima Asuri showed gratitude by sharing that their initiative could help the marine environment. I like that they are taking care of the mangroves. I hope these trees will not be destroyed so that the fish will not disappear. Thank you for helping us here. You are so kind. Mrs. Aika Amina Hussein shared how the mangrove rehabilitation started in Sitio Linao and have helped provide income for the residents of the community. I really do not know the name of their program, but workers of DNR come here to give mangrove saplings for tree planting. Usually, they come here 2 to 5 times a year. It also provided us income since they buy our saplings in black pots for 15 pesos. But when the lockdown happened, they are not buying from us anymore. They also have members go here to instruct us to place garbage cans in each house, but we could not avoid throwing our waste in the ocean. Only DNR gave us livelihood because they gave us fishing nets. But because of the lockdown, all of these services were gone. Unfortunately, a respondent also shared that illegal logging has been happening in the community where mangrove trees are cut and used as foundation for some of the houses. There is someone cutting down mangroves. He is a resident here. They have a technique to hide their cuttings. When they cut the mangroves, they place mud on the base of the tree to avoid getting busted. They use these woods as brace in their house. To avoid the base of the house from shaking, they put brace on it. Now that logging mangroves are prohibited, they go to the mountains and cut trees there. When asked about the ecosystem services provided by the mangrove forests, Mrs. Aika Amina Hussein shared that these trees protect them from large tidal waves during heavy storms. Since mangroves act as barriers against large tidal waves, if they disappear, no one will protect us. Even if the tidal waves are big and the wind are stronger and on the other side, our sitio never experiences that. That's why it is called Linao. Say, for example, in Tampuan, when the waves are large, they hide their boats here so that it won't be hit by the large waves. Moreover, three respondents shared the impact of the boardwalk it had on them. One of the respondents said that it had provided them with income from people who would visit the boardwalk. When the DNR created the boardwalk, people who visited our sitio must plant a mangrove sapling before they could proceed in the boardwalk. And that's the end of the presentation for the semi-structured interview surveys.
Hello everyone, I am Jessa B. Morin. I'm going to report our assessment on mangroves at Sitio Linao, Maasim, Sarangani Province. Here are my co-researchers, Philip John Naval, Eliza May Abulag, and Karen Mia Ligada. The biodiversity assessment site was conducted in Sitio Linao, Maasim, Sarangani Province from March 31 to April 3, 2022. The coastal and marine ecosystems and constituent species of the assessment stations were evaluated. Assessment site selection. Purposive sampling established mangrove forest assessment stations. 10% of the overall area would be analyzed. Then, it was split into stations to represent the ecosystem equally. At each sampling location, mangroves will be sampled from landward to seaward zones. A baseline transect parallel to the shore will be laid. Along with intervals of 20 to 30 meters, a nested 10 by 10 quadrat will be built at each transect line. The mangrove stand's extent will decide the number of plots along its transect. All trees inside the 10 by 10 meter quadrat with a diameter of at least 5 cm, growing to a height of more than 3 meters, will be identified and measured. Identification of mangrove species. Inside each 10 by 10 meter plot, a 5 by 5 meter plot is created, and all saplings, heights between 2 and 3 meters, are identified and counted. Similarly, a smaller 1 by 1 meter plot was created inside the 10 by 10 meter plot, and all seedlings within the smaller square are identified and counted. Community structure analysis. The data gathered was analyzed using the parameters population density, frequency, relative density, relative frequency, relative dominance, and the importance value. The below figure shows the formula of the given parameters. Shannon index gives an estimate of species richness and distribution. In Table 1 shows Fernando Scale 1998 criteria for relative values of Shannon Index H. Mangrove condition. Table 2 shows the habitat criteria rating chart for mangroves. In Sitio Linao, Maasim, Sarangani Province, we have recorded 4 mangrove species that belong to 3 different families. Rhizophoracea family obtained the highest species composition with 2 mangrove species, which are Rhizophora apiculata and Rhizophora macronata, followed by the family of Avicennaceae, which include Avicennia marina. The least abundant mangrove species was Soneratia alba. These are the mangroves community that are found in the sampling site. The Avicennia marina, or the api-api, the Rhizophora apiculata, or the bakaw lalaki, Rhizophora macronata, the bakaw babae, and the Soneratia alba, or the pagatpat. The DBH growth rates in mangrove forest in Sitio Linao, Maasim, Sarangani Province shows that A. marina has the highest DBH with a value of 100.17, followed by Soneratia alba with 86.32, R. macronata with 62.86, and R. apiculata with the least value of 46.41. In terms of relative frequency, our apiculata has the highest value with 36.33, followed by R. macronata with 30.46, A. marina 24.94, and lastly, with the lowest relative dominance is S. alba with 8.27. In relative density, A. marina has the highest density with 40.70, to be followed with R. apiculata 30.23, and R. macronata 22.67, and lastly, S. alba with 6.40. In relative dominance, A. marina has the highest relative dominance with 37.1, and the lowest is the Soneratia alba with 12.12. Results further revealed that of the 4 identified mangrove species, A. marina had the greatest importance value with 102.74%, followed by R. apiculata with a value of 90.86%, then by R. macronata with a value of 79.61%, S. alba found to be a relatively less important than the other mangroves, having an importance value of 26.79%. The Diversity and Evenness Index in Sitio Linao, Maasim, Sarangani Province shows that the classification is very low. It is according to the criteria on Fernando Scale 1998.
This video report is about the result and discussion of our assessment on seagrass. Proceeding to this slide is about assessment site. The assessment was conducted from March 31 to April 3, 2022 at Sitio Linao, Tinoto, located at Maasim, Sarangani Province. The coastal and marine ecosystems and constituent species of the assessment station were evaluated. Assessments of seagrasses were also conducted in macrobenthic ecosystems. You can see on the photo the location of 3 stations at Sitio Linao. The 3 assessment stations have been selected. Each station will be chosen using the BMB site selection criteria. Considering the ecosystem's dominating traits, these characteristics include density and patchiness and the distance to a potential source of impact. Data collection. The ecosystem was assessed using the belt transect method. Each station must have 3 parallel 50-meter transect lines separated by a 25-meter space. Perpendicular to the coast, transect lines should be placed from the shallow intertidal zone to a depth where seagrass is found. A GPS should indicate the start and finish of transect tapes. At 5-meter intervals, a 0.5 meter by 0.5 meter quadrat will be placed, commencing at the 0-meter point on the right side of each transect. Identification of seagrass species. The data recorder or the researchers will always walk on the left side of the transect to avoid disturbing the measured quadrats. A photograph of the quadrat will be taken at each interval to adjust for identification biases and ensure the accuracy of estimating seagrasses percent covered. Readings will be taken every 5 meters from 0 to 50 meters. Community structure analysis. From the data collected, the following formulas were used to compute the following biological information. So first, shoot density. It is an expression of the numerical strength of a species where the number of individuals of each species is divided by the area sampled. Density is calculated by the equation showed below. So the second is relative density or RD is the study of numerical strength of species in relation to the total density of individuals of all the species and can be calculated as follows. The third is frequency. It refers to the degree of dispersion of individual species in an area and usually expressed in terms of percentage occurrence. The fourth is relative frequency. It is the degree of frequency of individual species in an area in relation to the total number of all species occurred. The fifth one is average percent cover was obtained as their corresponding percentage cover inside the 0.5 meter squared quadrat. Threshold for evaluating seagrass condition. So the first is threshold for seagrass cover condition. The condition could be evaluated according to its percentage cover, such as 76% to 100% coverage means excellent, 51 to 75% coverage means good, while 26 and to 50% coverage means fair, and lastly 0 to 25% coverage means poor. Second is criteria used for evaluation of seagrass habitat. First, pristine seagrass beds. So the criteria for evaluation of pristine seagrass beds is it has higher low species diversity bordering land masses or islands far removed from human habitations, disturbed only by the normal intensity of natural elements, often form thick assemblages in shallow waters, and the management priority is high priority for protection and management. Disturbed seagrass beds. higher low species diversity in seagrass beds that occupy bays and covers near human habitations. These beds receive constant impacts of human activities such as light to moderate physical disturbance and various kinds of pollution that are not severe enough to eliminate or kill the seagrasses. Management priority is high priority for minimizing the existing human impacts in the area. Third is altered seagrass. The criteria for its evaluation is low species diversity, permanently and completely changed into other coastal uses like fish ponds, landfill, or heavily impacted by sedimentation and physical damage. While its management priority is low priority for management unless rehabilitation is still possible in area. So the fourth one is emergent seagrass beds. Its criteria is low species diversity largely controlled by extreme physico-chemical conditions such as low levels of salinity or variation thereof within natural environment. So its management priority is medium priority for management and conservation depending on controlling conditions. Diversity indices of seagrass. The first one is Shannon Index of General Diversity was determined using shoot count for all species as table 8 shown below. The second is Index of Dominance will be used to compare the dominance of same species in an area as shown by table 9. The third is Evenness is important to determine the distribution of species in a certain area as shown at table 10 as you can see. Proceeding to the result part. Sitio Linao, located at Tinoto, Maasim, Sarangani Province, has a seagrass bed sandy substrate mixed with shell debris in the area as reflected in Table 3. The area is composed of different seagrass species that seem to have zonation pattern. It comprises two seagrass families, Cymodocea, one genera and one species, and Hydrocharyticeae that has 3 genera and 3 species. Seagrasses are very susceptible to change in physical and chemical properties of the ocean, and with global warming, which is changing the temperature of the ocean. There are 4 species of seagrass found at Sitio Linao. These are Thalassia hemprechii, or sickle-leaf seagrass. Its percent cover is 24.45%, while its frequency is 75.76%, and its RF is 29.76%. Then, Cymodocea rotundata or smooth ribbon seagrass has percent cover of 13.2%, frequency of 54.55%, and its RF is 21.43%. Next is Inhalus acroides or broadblade seagrass. Its percent cover is 49.8%, frequency is 90.91%, and its RF is 35.71%. Lastly is Halophila minor or small spoon seagrass. Its percent cover is 13.78%, frequency is 33.33%, while its RF is 35.71%. Community structure. The average total of percent cover of seagrass in Station 1 was 17%, while the total percent cover of seagrass in Station 2 was 35%, and finally, the total cover of seagrass in Station 3 was 48%. So the seagrass that was analyzed was located near the shore, on the shallow intertidal area. The substrate on the area has a composition of both sandy and muddy, which implies that it was a perfect living condition for the variety of species found in the area. So the Inhalus acroides or Inhalus anchoroids yields the highest canopy height, which are 31 cm, 33 cm, and 35 cm of the haphazardly chosen leaf blades in the 3 different stations. On the other hand, it also has the highest percent cover in the area. Meanwhile, Thalassia hemprechii yields the second highest canopy height that has 13 cm, 14 cm, followed by Cymodocea rotundata which has canopy height of 11 cm, 12 centimeter and 13 centimeter. Lastly is Halopila minor, which is only present in station 3. It has a canopy height of 3 centimeter. Moreover, as shown in figure 6, the highest epiphyte cover was observed in station 3, which has 60.9%, followed by station 2 that has 41.82%, and lastly station 1 that has 26.43%. Seagrass species compositions of Sitio Linao, Maasim, Sarangani Province. So the first one is Cymodocea rotundata. It has long ribbon-like leaves. Their leaf tips are blunt and rounded. Also, they have smooth leaf tips. It is usually found in the intertidal zone in narrow leaf blades measuring 5 to 20 cm in length and 0.6 to 1.2 mm in width. The leaf tip is widely rounded and serrated. The leaf sheets are approximately 1.4 cm long, and Halodual pinifolia has a creeping rhizome with 2 to 3 roots at each node. Figure 9 shows the curved shape of its leaves characterizes Thalassia hemprechii or sickle seagrass. The leaf tips of T. hemprechii are usually round and smooth. It can also be found colonizing muddy substrates, particularly where water pools at low tide. Next is Inhalus acoroides. Inhalus acoroides leaves are the longest, that has 0.3 to 15 meter long among the Philippine seagrass species. It is also thicker than most of the strap-shaped seagrass leaves. In addition, it can grow on different sediment types, from silt to coarse sand. It can be found in sheltered bays, estuaries, or usually turbid and quiet. Lastly is Halopila minor. So this plant has small leaves, approximately 0.7 to 1.2 mm in width. Leaves became a set from two pieces that rise up from the rhizomes, and they are oval to elliptical, with every 6 to 10 veins given off toward right and left margins from the longitudinal vein. This species is found on muddy substrate in subtidal zones and in deeper places along shorelines with calm water movements. The references used is shown on this slide. That's all.
Today, I'm going to present about the macrobenthic invertebrates. The group members are yours truly, Jofel Tampoy, Christian B. Enriquez, Rio Castillo, and Sean Andre de Posa. So for the assessment site, we have the biodiversity assessment site was carried out in Sitio Linao, Maasim, Sarangani Province between March 31 and April 3, 2022. The coastal and marine ecosystems of the assessment stations and its constituent species were evaluated. For more specifically, macrobenthic invertebrates assessments were conducted in both the mangrove and seagrass ecosystems. For the assessment site selection, we have a total of 3 assessment stations established according to the ecosystem criteria prescribed by the BMB, or the Bureau of Management Board. Um, it also ensures that pseudo-replication of assessment sites was avoided by determining the site's distance from one another and the factors affecting the area's habitats, such as near a coastal community and coastal developments, as well as far from potential sources of disturbance. Now, for the data collection, the surveys consisted of day observations only. Two 50-meter belt transects with 2-meter observation width was laid on the intertidal areas parallel to the shore. Sampling for the macroinvertebrates included low tide reef walks, snorkeling in shallow water areas, and inspection of underside of rocks and crevices. All macroinvertebrates encountered over 5 meters were recorded and photographed. Now, for the identification of macrobenthic invertebrates, photographs taken during sampling were used to identify the species to the lowest possible taxon using guidebooks and published scientific journals. These include basic taxonomic skills and knowledge of the morphology of each species. For the community structure analysis, we used the relative abundance, relative density, relative frequency, Shannon's index diversity, and Shannon evenness index to measure or quantify the community structure. So for the relative abundance, it states that it is in the number of percent composition of an organism of a particular kind relative to the total number of organisms in the area. So the screen presents the equation 1 for the relative abundance. Next is the relative density, which is the study of numerical strength of a species in relation to the total density of individuals of all the species and can be calculated as follows. Next is for the relative frequency, which is the degree of frequency of individual species in an area in relation to the total number of species occurred. So we have the relative frequency is equal to frequency value for species A over total of frequency values for all species. For the diversity and evenness indices, we use the Shannon index of general diversity using the shoot count for the seagrass and the number of individuals observed in macrobenthic invertebrates and mangrove species. So the screen presents the table that describes the Shannon index and its relative values. Meanwhile, for the evenness index, it is used to determine the distribution of species in a certain area. So the, the screen presents the table with regards to the evenness index. So the evenness index and then the relative values. For the results and discussion, a total of 15 macrobenthic invertebrate species from 12 families were documented in the coastal ecosystems of Sitio Linao, Maasim, Sarangani Province. Diadema citosum was the most observed with 38 individuals, followed by Proteaster nodosus with 26 individuals, Narita species with 22 individuals, and Anadra antiquata with 17 individuals. The illustration on the presentation presents the macrobenthic invertebrate community structure. So for Proteaster nodosus or the horned sea star, we have 26 individuals with a relative abundance of 15.57% and a relative density of 0.29 individuals per meter squared. Whereas the Diadema citosum or the porcupine sea urchin had 38 individuals, um, relative abundance with 22.75%, relative density with 0.43 individuals meter per squared. And the rest of the species, such as the Lynchia levigata, the azure sea star, Arcaster typicus or the common sea star, Pentaster obtusatus with the blunt arm sea star, Holothuria atra or the lollyfish. Next is the Synapta maculata or the snake sea cucumber, Holothuria leucospilota or the black sea cucumber, Anadra antiquata, the antique art, Echinotrix calamaris or the banded sea urchin, Cyprea annulus or the ring cowrie, Nerita sp or the and next is the Laterolagena smaragdula or the precious stone shell, Terebralia palustris or the giant mangrove whelk. And the rest of these species were seen in both the seagrasses and the um, mangrove forest of, of Sitio Linao. So the community structure. Results revealed that Diadema citosum had the highest value in terms of relative abundance with 22.75%, relative density of 0.43 individuals per meter squared, and relative frequency of 0.08. It is then followed by Protoriastus nodosus with relative abundance from 29.55%, relative density of 0.29 individuals per meter squared, and relative frequency of 0.26. And the Rita species with 22.75% relative abundance, 0.42 individuals per meter squared, and 0.08 relative frequency. Meanwhile, the macrobenthic invertebrate species with the lowest value in terms of relative abundance, relative density, and relative frequency is the H. leucospilota. For the diversity and evenness indices, we have an H index of 2.30, which means that the diversity of the species in Sitio Linao is at medium. Meanwhile, the evenness index or the E index is at 0.85, which means that it It has high evenness. So the following are the references for our research. And that's it. That's the end of our presentation.
Good day, everyone. So now we are going to present to you the coral reef assessment conducted on Sitio Linao, Maasim, Sarangani Province last March 29 to April 3, 2022. So the members of the coral reef assessment are Hannah Crystal P. Lopez, Nico Malimping, and Angeline Palermo. The Philippines is part of the Coral Triangle, which comprises over 75% of all coral species and 35% of all coral reefs. Hundreds of coral species are found in the Philippines coral reefs, which are the second largest in Southeast Asia. Around 98% of our country's reef are fragile, with 70% facing a high or extremely high risk of deterioration. Coral damage is mostly caused by unsustainable fishing activities such as blast fishing and cyanide fishing. Corals are already under threat from direct human activities. These reefs are now being imperiled by global warming. So, the objectives of the assessment is first, to identify the composition of constituent species present in the coastal and marine ecosystems of the assessment site. Second, examine the condition of the coral reef at Sitio Linao, Barangay Tinoto, Maasim, Sarangani Province. And lastly, estimate the coral cover percentages within the examined area using observation and rational estimation of each habitat component. The findings of this study might aid the Protected Area Management Office of the Sarangani Bay Protected Seascape long-term coral reef monitoring activities. Such information might aid policymakers in revisiting and updating coral reef strategies. It will also assist in the development of initiatives that encourage sustainable practices and volunteer efforts in order to address the area's already dwindling coral populations. As a result, the purpose of this study is to monitor and learn more about the existing coral reefs in Tinoto, Sitio Linao. This data will also be used as a reference tool for future coral reef ecological investigations. Next is the methodology. So for our study site, the assessment was conducted at Maasim Mangrove Rehabilitation Center located at the coast of Sitio Linao, Barangay Tinoto, Maasim, Sarangani Province. So Sitio Linao is about 6.7 kilometers away from the barangay. As you can see in the picture, the map of the assessment site located in Sitio Linao, Maasim, Sarangani Province. So next, the assessment was carried out last March 29 to April 3, 2022. Stations are approximately 250 meters away from the shore. Where you can see in the image, the orange markers represent the assessment stations, and the reef flat was approximately 20 meters before the reef slope. Two transect lines were laid at each station, covering an area of 100 meters squared each. One in the reef flat, approximately 3 meters deep during high tide, and one in the reef slope, approximately 10 to 15 meters deep. Next is data collection. So the photo transect method was used to monitor the current state of the coral reef's cover and abundance of coral benthic life forms such as hard corals, soft corals, dead corals with algae, and the substrate. Using the global positioning systems, the coordinates of the sampling stations are found. The assessors dived underwater with an underwater housed camera or GoPro, and the documentation began at point 0, where a total of 100 quadrant or 1 by 1 meter quadrat was placed per 0.5 meters interval, then photographed at a distance. The photos taken were refined with photo editing software and analyzed using the Coral Point Count with Excel extension or known as CPCE software. The area covered by the quadrant were manually defined within the CPCE, where 10 random points were plotted and scored. The identified corals were then categorized into groups based on the type of growth information and morphology per genus. So for the identification, a field guide was used to determine the coral groups from the photographs of coral cover processed in CPCE software. Next, for the statistical analysis, so the photographs were analyzed using the software CPCE. A 1 by 1 meter area was manually defined within the photographs and then overlaid with 10 random points. To determine the condition of coral reefs, a threshold for hard coral cover or HCC from Liquanen et al. 2017 and live coral cover LCC from Gomez et al. 1981 were utilized. So, live or hard plus soft coral cover scale is categorized as 0% to 25% as poor, 25% to 50% as fair, greater than 50% to 75% is good, and greater than 70% is excellent. Next is hard coral scale cover. 0% to 22% is poor, 22% to 33% is fair, 33% to 44% is good, and lastly, 44% is excellent. The LCC is the percentage cover of hard corals and soft corals, while HCC is the overall percentage cover of hard corals. Then a scale is utilized to categorize the reef conditions such as poor, fair, good, or excellent in status. Next is the results. There are a total of 22 major categories that were analyzed using the CPCE software. Soft corals have the highest percentage cover with 30.46%, followed by Poritidae with 15.23%, dead coral 11.73%, and Acroporidae with 10.43%. Overall hard coral cover of Sitio Linao, Tinoto Maasim is fair, while the live coral cover is good. The status and condition of coral reef habitats may provide supplemental information. A diversified coral community is essential for sustaining coral reef ecosystem services in addition to a high number of individual corals and increased coral cover. Acropora and Porites appears to be the most abundant families of corals in the assessment sites, and are also commonly documented in most parts of the coastal waters of the Philippines. These corals are reef-building corals, meaning they are essential components of coral reefs. The stronger a reef's potential to create and sustain certain ecological services, the more corals it has. So now, you can see the actual photos of corals from the assessment site. So, diverse coral communities and high number of individual corals are needed to sustain coral reef ecosystem services and increase coral cover. Consider the dozen or so species of arborescent or branching staghorn Acropora, which add to a reef's architectural richness. These corals are bleach and sediment sensitive. Acropora pulchra, an arborescent coral, can tolerate bleaching in murky nearshore waters. The more environmental pressures a reef can tolerate, the more redundant its ecological services. Coral diversity can be utilized to identify reefs with a higher capacity to withstand pressures and disturbances. Changes in coral species composition and diversity show reefs' declining ability to maintain ecological processes. Coral diversity and cover must be assessed for this reason. This method of monitoring can help detect endangered coral species. So that's all for the coral reef assessment in Sitio Linao, Tinoto, Maasim. Thank you so much for listening.
Reef Fishes by Gahol Hanilin, Petalverojoan, and the Ragarugine cresta. The study aims to identify the species composition of reef fishes in the assessment site and evaluate the reef fish condition. The study, or the biodiversity assessment, was conducted in Sitio Linao, Maasim, Sarangani Province from March 31st to April 3rd, 2022. 3 slumping stations was established in the study site for coral reefs ecosystem and reef fish assemblages, in which the transect utilized to assess the corals was also used to determine the associated reef fishes through fish visual senses. The researchers used the abundance and biomass formula in order to analyze their data, in which abundance is equal to the number of individuals over the area covered, and biomass is equal to the value of A multiplied to the length of the individual raised to the V value. The researchers also used the Diversity Index by Fernandez scale, in which 1.9 and below is categorized as very low, 2.0 to 2.49 is low, 2.5 to 2.99 was moderate, 3.0 to 3.49 was high, and 3.5 and above was very high. The figure shown is the coastal resource map where the study was carried out. The highlighted area is where the fish assemblages was assessed. A total of 41 reef fish species was recorded, where 12 of which belongs to distinct reef fish families. During the assessment, a total of 1,042 fish individuals was recorded, namely individuals from the family Pomacentridae, lemon damsel, black bear chromis, charcoal damsel, spiny puller, swallowtail puller, blue axle chromis, brown damsel, humpback dacilus, neon damsel, blue-green puller, ambon puller, staghorn damsel, barhead damsel, violet damosel, white belly chromis, Clark's anemone fish, and pink anemone fish, or the damsel fishes. From family Aridae, striped catfish. From family Labridae or the wrasses, blue strictly wrasse, green moon wrasse, pinstripe wrasse, and eclipse pigfish. From the family Pyracanthidae or the ray-finned fish, blue-eye cardinal fish, and wolf cardinal fish. For the family Zanclidae is the Moorish idol. For the family Mulidae is the banded goatfish. Family Serranidae or the sea bases, blue-spatted rockroad, and threadfin antheas. For the family Lathrenidae or the emperor breams, big-eye sea bream. For the family Pumacanthidae or the angelfish, pure-scale angelfish, and bicolor angelfish. For the family Ostracidae or the boxfish, black saddle stobie. For the family Holocentridae is the East Indian soldierfish or swirlfishes. And from the family Catodontidae or the butterfly fishes, vagabond butterfly fish, pennant bannerfish, horned bannerfish, teardrop butterfly fish, long-nosed butterfly fish, redfin butterfly fish, and double saddle butterfly fish. Species interactions are critical ecological mechanisms shaping and regulating biodiversity. However, not all species have the same impact on the environment, and keystone species are those that have a disproportionately significant impact compared to their number. They have an effect on ecological processes by managing prey populations and predator populations, supporting other species through cooperative interactions, uniting mutualistic species, and establishing environments that affect nearby species. In Sitio Linao, results reveal that the family of Pomacentridae or the damselfishes had the highest number of individuals recorded during the assessment. This occurrence suggests that the increasing damselfish populations may be due to a lack of predators such as groupers and snappers. This occurrence was observed in Caribbean reefs. Pumacentrus molosensis, or the lemon damsel, from the family of Pomacentridae were found to be the most abundant reef fish when calculating community proportion based on abundance, representing 64.72% of all depths recorded in which 212 individuals were found. This occurrence suggests that increasing damselfish populations may be due to a lack of predators such as groupers and snappers. This occurrence is also observed in Caribbean reefs. Furthermore, the high abundance of these damselfish could be an ecological indicator of coral reef degradation boosted by damselfish gardening activity, which can increase nutrient loads and facilitate fleshy macroalgal cover, resulting in a reduction in hard corals and structural complexity, according to Ranzato. Anthropogenic factors like habitat modification and fishing pressures can impact the abundance and distribution of fish species. For example, in Sitio Linao, during the assessment, the total fish abundance varied between different depths and different stations. 5 reef fish families were seen in the shallow and deep areas: Pomacentridae, Labridae, Chaetodontidae, Bracanthidae, and Mollidae. Meanwhile, 6 reef fish families were only recorded in the deep area, namely family Serranidae, Pomacanthidae, Zanclidae, Lathranidae, Holocentridae, and Ostracidae. On the other hand, Aridae was the only recorded reef fish family in the shallow area. Total biomass differed significantly between sites. In deep water, Pomacentridae has the highest biomass, which is 103.91 grams per meter squared, followed by both Mollidae and Ostracidae, which is equals to 28.16 grams per meter squared. Chaetodontidae equals to 24.88 grams per meter squared. Labridae 15.27 grams per meter squared. Zanclidae 11.78 grams per meter squared. Lathranidae 4.10 grams per meter squared. Serranidae 1.78 grams per meter squared. Pomacanthidae 0.79 grams per meter squared. And Holocentridae 0.24 grams per meter squared. Aridae and Bracanthidae had no evaluated biomass. Meanwhile, in shallow water, Pomacentridae has the highest biomass, which is equals to 49.67 grams per meter squared, followed by Mollidae 5.39 grams per meter squared, Chaetodontidae 2.87 grams per meter squared, Aridae 2.82 grams per meter squared, and Labridae 1.99 grams per meter squared. However, the rest of the reef fish families such as Ostracidae, Zanclidae, Bracanthidae, Holocentridae, Lathranidae, Pomacanthidae, and Serranidae had no evaluated biomass since some families were not recorded in shallow water. The results show that fish abundance and biomass gradually increase when the depth also increases, apart from the family Aridae, which is not present in the deep water area. Also, fewer reef fish species were observed in the shallow area, whereas many reef fishes were found when the depth increased. These results suggest that fishing pressure may have an adverse effect on the abundance and biomass of reef fish species. In a healthy ecosystem, a diverse and balanced number of species exist. To maintain the balance of an ecosystem and to make a more efficient, productive, and sustainable ecosystem, it is essential to maintain high species diversity. During the fish visual census in Sitio Linao, Barangay Tinoto, Maasim, Sarangani Province, results show that the Shannon-Wiener diversity index of all the reef fish species recorded was 2.61, which indicated a moderate reef fish biodiversity. It is essential to continue improving our understanding of all potential reef health stressors. For example, the multiple effects of nitrification, fishing, and carbon dioxide increase, which may provoke a loss of coral reef resilience, resulting into the decline in reef fish population. Still, it is also vital to pay attention to community interactions and feedback, which are direct consequences of the stressors affecting coral reefs and may amplify wicked resilient regimes dominated by, for example, fleshy microalgae.
In this report, I am going to discuss about the inventory of phytoplankton during the assessment in Sitio Linao, Barangay Tinoto in Maasim, Sarangani Province. The researchers of this assessment were Luigi Manyoza, Arnold Solamo, Precious Grace Tukib, and yours truly, Manlangit Robert. The biodiversity assessment site was carried out in 2 stations in Sitio Linao, As you can see in the picture on the right side of the presentation, on March 31 to April 3, 2022, the coastal and marine ecosystems of the assessment stations and its constituent species were evaluated in this assessment. Phytoplankton samples were collected vertically, towing a canonical planktonnet with a length of 0.65 meters, a mouth diameter of 0.21 meters, and a mesh size of 25 micrometers from a depth of 10 to 15 meters and up until the surface. The collected samples were contained in a bottle and preserved with 1 drop of Lugo solution and formaldehyde. The quantitative analysis samples were maintained with 3 ml of Lugo solution. Generally, a clear yellowing of the sample indicates that the proper amount of Lugo solution has been added sufficiently. 1 liter samples collected during the sampling were preserved in the cooler for counting and phytoplankton identifications. The standard methods of sample preparation and microscopy were utilized from the methodologies of Borja 2012. So as you can see here, we have our materials during the field sampling of phytoplankton assessment. First one is the styrofoam or the ice bags, where the 1 liter samples were stored for preservation, and the chemicals were Lugo solution for preservation and dyeing, and 30% formaldehyde for preservation. Phytoplankton was identified to the genus level by observing the cell's morphological characteristics under the light microscope. With the aid of several identification guides from references such as Identifying Marine Phytoplankton by Thomas 1997, Marine Phytoplankton Atlas of Kuwait's Waters by Al-Kandari et al. 2009. An online taxonomic database, the World Register of Marine Species, or most commonly known as WORMS, and the algae base was also used to correct the scientific names from older publications and match them with the most current accepted scientific names. The Shannon-Wiener index equation was also used to measure the biodiversity of phytoplankton in Sitio Linao. So the equation goes as the negative summation of pi times ln pi. So the h indicates the index of Shannon-Wieners. Pi is the proportion of total sample represented by species, and this can be solved by dividing the number of individuals of species to the total number of samples or species. The Fernando 1998 scale was used as the diversity criteria for our Shannon index value. According to Fernando, a Shannon index value greater than 3.5 indicates a very high diversity, and a Shannon index value less than 1.9 has a very low diversity. For the results, there were recorded 23 phytoplankton genera identified in the 2 sampling stations of Sitio Linao, Maasim, Sarangani Province. These species are categorized among 3 major taxonomic groups based on their specific classifications, namely cyanobacteria, diatom, and dinoflagellates. So as you can see, here are the actual photographs of the identified genus in the 1 liter samples that we've collected in Sitio Linao. So we have Helicotheca, Ginardia, Cossinidiscus, Hemialulus, Stephanopixis, Chaetocerus, Protoperidinium, Serratium, Pyrophacus, Formidium, Oscillatoria, and Thalassoneमा. Sitio Linao has a total of 23 genera of phytoplankton comprised mainly of 18 genera in Station 1 and Station 2 respectively. There were 16,109 individuals recorded in Station 1 and 47,406 individuals in Station 2, which would equate to an overall abundance of 63,513 individuals. The overall result was dominated by cyanobacteria, oscillatoria, and formidium. As reflected in the study, the overall mean density of Sitio Linao was 63,517.62 cells per liter, an abundance value of 33,000 cells per ml, and has 3 major classes: Bacillariophyceae, Cyanophyceae, and Dinophyceae. The Cyanophyceae was the most abundant and has the highest cell density in the sampling site, represented by Oscillatoria and Formidium. The presence of oscillatoria indicates higher nutrient status, and this nutrient increase caused by agricultural and organic waste discharge together with other anthropogenic activities along the shore has most likely influenced phytoplankton composition in the study area. The parameters of the selected diversity indices such as species diversity provide information about the structure and organization of plankton communities. The values of the indices are used to determine the condition of the water system. In the case of Sitio Linao Maasim, the computed diversity value in this present study, which is 1.301, is very low based on the Shannon-Wiener diversity scale developed by Fernando 1998. According to Margalef, phytoplankton diversity is typically between 1 and 2.5 in coastal waters, 3.5 to 4.5 in oceanic regions, and 5 in open tropical oceanic environments where phytoplankton have low productivity but a wide variety of species. Based on the data presented, the researchers studied the distribution, diversity, and abundance of phytoplankton in Sitio Linao's coastal waters. The following conclusions were drawn. The study area is composed of three primary phytoplankton groups that consisted of blue-green algae with 2 genera, diatom with 18 genera, and dinoflagellates with 3 genera. Cyanobacteria dominated both study stations, with Oscillatoria being its abundant genera, followed by Formedium. Diatoms has the highest number of genera recorded during the sampling period with 18 genera. Dinoflagellates were the least abundant of these organisms with 3 genera, namely Ceratium, Protoperdinium, and Pyrophacus. Based on the data gathered, the area has a mean density of 63,517.62 cells per liter. The status or condition of the phytoplankton community of the assessed area is categorized as a very low diversity following the criteria from Fernando Scales 1998 category for Shannon's index. Assuming phytoplankton spread is not limited by dispersion, the local environmental variables influence the phytoplankton community structure in Sitio Linao. Thus, the researcher recommends phytoplankton diversity indices can be employed to evaluate pelagic ecosystem health. Monitoring phytoplankton can also provide feedback on the influence of land use and fertilizer inputs on water quality. Also, future phytoplankton studies should attribute water quality parameters to natural and anthropogenic causes to gain a deeper understanding of the phytoplankton composition and abundance at Sitio Linao. Also, phytoplankton monitoring should be conducted and institutionalized to determine the impact of nutrient loading on coastal waterways, particularly in Sitio Linao, Sarangani Province. That is all for this report. Thank you.
Good day, everyone. This is the presentation of our group regarding the assessment in zooplankton in Sitio Linao. Zooplankton is defined as floating, ecologically significant organisms that are a key part of the food web and also serve as an indicator of the ecological status of water bodies. Ecologically, zooplankton is one of the most influential biotic factors in all functional elements of an aquatic system, including food chains, food webs, energy flow, and matter cycling. The population of zooplankton is a helpful indication of the biological, physical, and chemical processes of an aquatic system due to its sensitivity to environmental variables and rapid response to changes in water quality. Many different species of organisms make up the marine zooplankton group, varying in sizes from microscopic protozoans to animals that are several meters long. The purpose of this study is to compile a zooplankton inventory in the coastal waters of Sarangani. As you can see, this is the map where the assessment takes place. So the objectives for this assessment is to first define the spatial distribution of zooplankton species, their composition, diversity, and abundance. Next is to determine the significance of the variation in zooplankton diversity between research site stations. This paper will specifically address the following questions. How dense and abundant zooplankton on average basis in Sitio Linao? Which zooplankton groups are the most abundant of the research site? What implications do zooplankton data collected at the study site have for coastal resource management? Due to the critical role zooplankton plays in the marine food chain and its significant impact on global environmental balance, this study will be conducted to determine zooplankton composition, diversity, and abundance of the coastal water in order to contribute data or critical information to aid in the proper conservation, protection, and management of this vital marine ecosystem. Significantly, this research will aid students, professors, and prospective researchers develop a better understanding and awareness of zooplankton in the coastal waters in Sitio Linao, Maasim. This study will enable future researchers to use the collected data and contribute to developing a comprehensive set of baseline data. The data collected can be used to help conserve marine resources by contributing to the scarcity of studies to develop refined marine resource and habitat management programs. A total of 2 assessment stations were outlined for zooplankton with depths ranging from 10 to 15 meters. It was carried through undergoing site visit in Sitio Linao, ground truthing, and georeferencing using Google Maps. At each sampling site for zooplankton, samples of plankton communities are collected using a student net with a mesh size of 100 micrometers and a mouth diameter of 0.3 meters. The plankton net is lowered to a depth of about 10 to 15 meters depending on the light penetration using a Secchi disk depth, and raised at a rate of not higher than 1 meter per second. The volume of water sampled is calculated by the area of the mouth of the plankton net times twice the depth the net was lowered. All net tows are conducted during 10 a.m. to 2 p.m. The concentrated sample of water collected at the cod end is then transferred to an adequately labeled bottle. Zooplankton samples are preserved immediately after collection with 95% ethyl alcohol. All samples will be allowed to stand undisturbed for about a week to allow organisms to settle at the bottom of the container. For zooplankton samples, at a 1 ml aliquot subsample is placed on a Sedgwick slide with 3 replicates and will be examined under our microscope. Plankton organisms are identified to the order or family level whenever possible and their numbers counted. Density was determined using the formula below from Newell and Newell, 1963. The identification of zooplankton will be guided through Yamani. For the results, at both stations, a total of 13 orders of zooplanktons were identified with a predominance of copepod, which accounted for 68% or a total of 212 individuals, and of which 57% is from the calanoid family. In addition, Table 1 demonstrates that the group of copepod is plentiful at both stations, with over 90 individuals at each location. Analysis of relative abundance by area revealed that copepods dominated the first station and the second station with a total of 111 and 103 individuals respectively. In the first station, the Calanoida order was followed by Aphramogphora and Cyclopoidea. Aphramogphora also occupied the second place at the second station with 6.67%. It was afterwards succeeded by class Cyclopoidea with 4.13%. Except for the classes Harpartocoida and Sponoida, 10 species were found in the first station and they were also present in the second station, except for Salfida and Trochea. A spatial distribution of copepods and other zooplankton densities is presented in this figure. A high density area of zooplankton with a total of 1,722 individuals per cubic meter was located in the second station. As for the other station, the density recorded was over 1,333 individuals per cubic meter. The zooplankton with the highest density in either station is the class Calanoida, with 758 individuals per cubic meter and 1,000 individuals per cubic meter in the other station. It is then followed by Aphragmophora with 216 individuals per cubic meter in Station 1 and 233 individuals per cubic meter in Station 2. The most dense out of all zooplanktons recorded in Sitio Linao, Maasim are the copepods with 68% or 212 individuals in total. Copepods are often dominate the zooplankton biomass in the modern ocean and are thought to be the most prevalent metazoans in the ocean and possibly on Earth. The reason behind this lies in their physical characteristics, which is unique. Catognaths are the second most abundant zooplankton in Sitio Linao. This is likely due to the high density of copepods in the area. Catognaths are present in all marine environments including the bentos, all local water zones, and the open ocean. As the major predators of copepods, they serve as a vital role in the marine food chain despite their modest size. Larvaceans are gelatinous zooplanktons that inhabit the majority of seas, coastal waterways, and estuaries, and are believed to be substantial consumers of the ocean's primary output. They are also the third most abundant and dense organism in the zooplankton community in Sitio Linao. These pictures here represents the species found in Sitio Linao, Maasim. The area around Sitio Linao is deemed to have a medium diversity with medium stability of zooplankton within the community. This may indicate that the organisms in the area are living in so-so conditions. In terms of calculating for the species richness in an area, the greater the index, the greater diversity of species in the habitat. The diversity of species in a particular region is dependent not only on the number of species present but also on the abundance of those species. Richness is measured by the number of species in an area, while evenness is measured by the relative abundance of species. Both are indicators of diversity in which the results gather from the site. It shows that the zooplankton community in Sitio Linao is falling on critical zone and that can still change in the future. In conclusion, the study area is composed of 5 primary zooplankton phylum, Annelida with 2 orders, Arthropoda with 4 orders, chordates with 3 orders, mollusks with 3 orders, and the phylum Catognatha with 1 order. Class Hexanophlea dominated both the study stations, with Calanoida being its abundant order, followed by Catognathes. The phylum Arthropoda have the highest number of genus recorded during the sampling period with 4 orders. The study has recorded that mollusks are the least abundant of all the zooplankton species, with 3 orders Bivalvia, Venerida, and Theropoda. The area has a density of 3,055.66 individuals per cubic meter based on the total density of zooplankton gathered. According to the criteria Citorus 2009, the status of condition of the zooplankton community of the area is categorized as a shallow diversity following the criteria. Despite the limitation of the present study, this paper nevertheless provides a relevant basis for further studies of zooplankton in Sitio Linao, Maasim, Sarangani. Such a study should include intraseasonal, interseasonal, and interannual analysis of zooplankton distribution in the region. Other studies can also include gathering data from various depths. It is also recommended to use a different type of net. This may provide a key basis for resource conservation and fisheries management on local and regional.
Good day, everyone. This is Fatima Clavesillas, and together with me are Claudine Matulak and Christian J.B. Redesendo. And we are to report our assessment entitled Sea Surface Current Velocity Profile of Sitio Linao, Tinoto, Maasim, Sarangani Province. This is in partial fulfillment of our requirements in MRB 148, Integrated Coastal Marine Resources Management.
Hello, my name is Christian J. Lucendo, and I'm here to show my part of the presentation, which is the abstract and the introduction. So let's begin. So, Sitio Linao, which can be found in Maasim, Sarangani Province, hosts different marine ecosystems, and the physical movement of water is of significant contribution to its rich marine resources. However, nothing was known about the sea surface currents prevailing in the area. Thus, the assessment was conducted to investigate the sea surface movement in Sitio Linao. The assessment was done in Sitio Linao in April 1, 2022. The methods used during the field conduct includes the flow field method using 2-meter cylindrical jogs and a global positioning system, which is known as the GPS. So the maximum flood tide sea surface current speed is 36.46 centimeters per second, which is observed beyond the intertidal flat and reef slopes of Sitio Linao with a southeastward direction, while the minimum surface current is going southward with a speed of 1.05 centimeters per second, which is found in the inner part of the intertidal flat directly facing the mangrove forest in area. The average surface current during the flooding tide is 17.4 centimeters per second, while the maximum ebb tide sea surface current speed is 108.52 centimeters per second, which is observed in the southern part beyond the reef slope with a southward direction, while the minimum surface current is going southwestward with a speed of 0.3 centimeters per second, which is found in northern area beyond the mangrove forest and the reef slopes. The average surface current during the ebbing tide is 19.78 centimeters per second. Offshore currents and cross-shore currents are observed during flooding tide, while longshore currents are observed during ebbing tide. These currents may imply that nutrient distribution and possible transport of pollutants. The findings of this assessment will help shape the direction of the integrated management planning that vitally includes solid waste management and water quality improvement and reintegrating policies that local governments will undertake, which in turn benefit the community and the marine ecosystems. And now let's proceed to the introduction. So the ocean is a vast basin that is composed of complex dynamics of features. It covers more than 70% of the planet's surface and is so immensely deep that it contains over 90% of the inhabitable space for life on Earth. Surface currents control the motion of the top 10% of the ocean's water. Current velocity is a key parameter in oceanography, and its direct measurement is important for oceanographic study and environmental monitoring. That is why sea surface current measurements are important for shipping, commercial fishing, recreational boating, and safety. Surface currents also play a role in regulating the planet's weather, climate, oxygen, and temperature. Until recently, in different coastal settings, not much was known about the strength of surface currents, in what direction they flow, how rapid surface water flow patterns change with time or location, how current patterns affect creatures that live in the coastal area, and how currents transport pollutants. The velocity and general pattern of sea surface current in Sitio Linao would be beneficial in a way that a key oceanographic information can be obtained, and findings of the assessment will guide local communities and governments for further marine conservation, protection initiatives, and strengthen management efforts. The objectives of this assessment is to describe the direction of the surface current during the ebbing and the flooding part of the tidal cycle, and which part of the study area do the currents move fastest during ebbing and flooding tide, and which portion of the study area has the highest temperature and salinity levels. Significance of the assessment is that this study will serve as a guiding document of the sea surface current velocity profile of Sitio Linao in Barangay Tinoto, Maasim, Sarangani Province during the ebbing and flooding tide, and this may help improve the draft coastal resource management and improve water quality and waste management, as well as findings that would help explain how surface currents affect the nutrient transport and larval dispersion of the area.
So, study site. So, figure 1 shows the map of the Philippines, Mindanao, and the study site, which is the Sitio Linao, Tinoto, Maasim, Sarangani Province. So, the sea surface current measurement was carried out in Sitio Linao, Maasim, Sarangani Province on April 1, 2002. So, Sitio Linao is known for its thick mangrove forest, seagrass beds, intertidal zone, fishes, and coral reefs. In line with the map shown in the previous slide, Table 1 shows the guide waypoints for the sea surface current drug deployment in Sitio Linao. Here we have the 3 stations, their waypoints, latitudes, longitudes, and bearing. Sampling hours for ebbing and flooding tides are done on specific period of the day as shown in Table 2. The sampling hours are based on WX Tide 32 version 4.7, a tide prediction program. So field measurements and deployment of drugs. Drugs are objects that float on water's surface and move with a surface current. The major assumption is that the drug moves at nearly the same speed as the current. Drugs with only slightly positive buoyancy are more likely to move at the current speed than lighter drugs. That was according to Hodges of 2002. A drug is designed to measure the Lagrangian water movement at a predetermined fixed depth. It provides in many situations, as suitable means of measuring currents and diffusive properties of coastal waters, estuaries, and lakes. That was according to Grandson and Stevenson of 1977. So, current drugs are made of two metal steel rings attached to each end of a 2-meter-long circular GINA earth cloth and suspended vertically in the water by a buoy. Each drug will be released approximately 50 to 80 meters away from each other within the sight of a 2 to 3 meter depth. In the releasing of drugs, the flow field method will be used. That was according to Grandson and Esvenson of 1977. It will be released in succession following the mapped sampling stations. Drugs will be retrieved immediately 10 to 15 minutes after the first drug is deployed, traversing the same path of the drug deployment. Using a handheld global positioning system, coordinate points will be recorded. Also, temperature and salinity at certain points in the station will be recorded. In addition to analyzing the current pattern, different coastal currents will also be observed and recorded. So, Table 3 shows the different coastal currents utilized to determine current patterns. So, those coastal currents are the longshore current, offshore current, cross-shore current, and reef currents. Data analysis. So according to Joseph of 2014, the Lagrangian method of fluid dynamics will be used in measuring the current velocities, since this method provides a quantitative description of both track and speed of flow, as if often employed to obtain an overall picture of oceanic water currents over large areas. The graphical presentation of the measured current will be plotted using Golden's Software's surface mapping software, Surfer version 20, and the distance and angle against north calculation will be computed using a map source. Current velocities will be plotted as two grid vector maps with polar coordinate system. Kriging method of gridding that was according to Bolling of 2005 will be used. The plotted vector maps will be overlaid to real satellite aerial images from Google Earth Pro of 2020. The post map of the bay will be also plotted using the same Surfer version 20 to determine the location of the drug deployment. Descriptive statistics were computed after the data are processed using Microsoft Excel to calculate the minimum, maximum, and average current speed for Sitio Linao during the said monsoonal period. Current velocities were expressed in centimeters per second as per Mel of 1980. The data for ebbing tide and flooding tide sea surface current of Sitio Linao are plotted through Google Earth Pro to picture out the overall track of drugs all over the area. The path of every drug indicates the movement of sea surface current.
As for the results and discussions of this assessment, sea surface current prevailing in Sitio Linao, Barangay Tinoto, Maasim, Sarangani Province, on the flooding and ebbing part of the tidal cycle using cylindrical drogues was investigated. For the whole duration of the conduct, there is a total of 26 drogue deployments in the whole stations for flooding tide. Approximate total duration of sea surface current sampling during the flooding tide was 2 to 3 hours. On the other hand, there is a total of 19 drogue deployments for ebbing tide. The approximate total duration for the sampling during ebbing tide was 2 to 3 hours. During flooding tide, the maximum temperature is 29.8 degrees Celsius, while the minimum temperature is 26 degrees Celsius. The average sea surface temperature during flooding tide is 28.28 degrees Celsius. The minimum, maximum, and average sea surface salinity of Sitio Linao during flooding tide are shown in Table 6. The maximum salinity is 33.1 ppt, while the minimum salinity is 29.6 ppt. The average sea surface salinity during flooding tide is 31.53 ppt. During the ebbing tide, the maximum salinity is 31 ppt, while the minimum salinity is 27.9 ppt. The average sea surface salinity during ebbing tide is 29.51 parts per thousand. As you can see, we have our sea surface current velocity results through our table and figure. So the minimum, maximum, and average sea surface current speed of Sitio Linao during flooding tide are shown in Table 8. The maximum current speed is 36.46 centimeters per second, which is observed beyond the intertidal flat and the reef slopes of Sitio Linao, with a southeastward direction, while the minimum surface current is going southward with a speed of 1.05 centimeters per second, which is found in the inner part of the intertidal flat directly facing the mangrove forests in the area. So please see Figure 1. The average sea surface current during the flooding tide is 17.04 centimeters per second. On the other hand, the minimum, maximum, and average sea surface current speed in Sitio Linao during ebbing tide are shown in Table 9. The maximum current speed is 108.52 centimeters per second, which is observed in the southern part beyond the reef slope with a southward direction, while the minimum surface current is going southeastward with a speed of 0.03 centimeters per second. And this is found in the northern area beyond the mangrove forests and reef slopes. The average surface current during the ebbing tide in Sitio Linao is 19.78 centimeters per second. Currents may be referred to according to their forcing mechanism as either wind-driven or thermohaline. Alternatively, they may be classified according to their depth, surface, intermediate, deep, or bottom. In a coastal setting, currents are highly significant for the larvae generation and distribution, where these are highly concentrated, as well as the nutrients, pollutants, and sediments pulled from the coastal runoff are introduced and circulated into the open ocean. The coastal areas are highly influenced by the rise and fall of tides and the wind stress that flow alongshore and offshore. As observed during flooding tide, there are longshore currents in the offshore region that is directed southward. In the inner portions of Sitio Linao, currents go in an inward manner, westwardly, following the contour of the shallow intertidal flat. This eventually become cross-shore currents, and this could be due to the wind blowing in the certain area and the feature of the whole intertidal flat. On the other hand, longshore currents are mainly observed during ebbing tide. This current ran parallel to the shore, which ranges from 18.19 centimeters per second to 35 centimeters per second, flowing southward. The cross-shore currents observed during falling tide and the longshore currents noted during both tidal cycle may imply that these currents can carry and distribute possible nutrients. In the case of both tidal cycles, where longshore currents are observed at the offshore region, nutrients and possible pollutants may be carried southward. Conclusion and recommendations. So for our conclusions, first, flooding tide sea surface currents of Sitio Linao has an average speed of 17.04 centimeters per second, which is found in the southern portion beyond the reef slopes. During flooding tide, cross-shore currents and longshore currents are observed in the area. Ebbing tide sea surface current has an average of 19.78 centimeters per second. It is observed beyond the reef slopes in the southern portion, which is the same with the flooding tide. Longshore currents are dominantly observed in the area. These currents, especially the longshore current, flow southwardly and vital for the distribution of nutrients in the area. The current flow during ebbing and flooding tide may be due to the tide's wind direction, underwater topography, and other affecting variables that can alter the sea surface velocity. Average sea surface temperature during flooding and ebbing tides are 17.04 degrees Celsius and 19.78 degrees Celsius, respectively. The average sea surface salinity during flooding tide and ebbing tide are 31.53 ppt and 29.51 ppt, respectively. It is highly recommended that this surface current profiling be observed thoroughly, and further studies correlated with satellite imaging should be employed, especially by the concerned agencies and organizations, both public and private, as well as the local government, in order to achieve a more detailed surface current information in the coastal areas, not only in Sitio Linao. Subsurface current measurements should also be conducted alongside surface currents in order to find out the interaction of the two. The contribution of concerned public and private institutions can achieve a more detailed result and assessment on the current pattern and its influence to nutrient dispersion, water quality, and other scientific aspects of Sitio Linao. With that said, resource management and solid waste management not only in Sitio Linao but the whole coastal waters of Sarangani Bay will be even more strengthened. Furthermore, this study should be updated annually in order to generate a trending report, especially for both southwest and northeast monsoons. The following photos or videos that will be shown are the group's documentations for the whole duration of the sea surface current conduct in Sitio Linao. Drop. Taro nga lang. Taro nga lang. Sige, taro nga lang. Sige, hulog na siyang isa.
Last namin nga drog, no?
Naa pa. Patindoga, patindoga. Sige. Sagdi lang, sige lang. Unsa matindoga na iyan. Sige.
Let's go!
Sige, dito ya.
Ikaw na ni Batio.
For the summary of findings, for mangroves, a total of 4 species from 3 different families were recorded. These include Rhizophora apiculata, Rhizophora mocronata, Avicennia marina, and Soneration alba. The Sitio Linao had medium diversity of mangroves, whereas it also has medium evenness. For the seagrasses, a total of 4 species were recorded. These include Cymodocea rotundata, Thalassia hemfrichi, Hinhalus acoroides, and Halophila minor. Station 3 had the highest cover, whereas E. acoroides had the highest seagrass cover. The overall seagrass cover in Sitio Linao is at 53.33%. Eacoroides had the highest canopy height. Meanwhile, the highest epiphyte cover was in Station 3. Furthermore, Station 2 and 3 has good seagrass condition, whereas Station 1 has poor condition. The seagrass community of Sitio Linao had medium diversity and medium evenness. For the macrobenthic invertebrates, a total of 15 species from 12 families were documented. Diadema cetosum was the most observed, followed by Protoriaster nodosus, an unspecified species of Nerita, and lastly Anadra antiquata. Most species documented primarily inhabit the seagrass meadows and mudflats of the mangrove forests. The macroinvertebrate community of Sitio Linao had medium diversity, but it has high evenness. For the coral reefs, among the species, results revealed that soft corals have the highest percentage of cover, followed by Poritidae, dead coral, and Acroporidae. Soft coral is more abundant in the reef flat areas than in the reef slopes. Acropora branching and Porites massive were the most common coral types found at the assessment stations. The results indicated that the overall hard coral cover of Sitio Linao is fair, while the live coral cover is good. The majority of coral reefs have been deteriorated in regions where residency have been developed, implying that the environment has been affected by human activity. In Sitio Linao, assessors recorded 41 reef fishes belonging to 12 families of reef fishes. Pomacentrus mollucensis, or the lemon damsel from the family of Pomacentridae, were found to be the most abundant reef fish species at all depths when calculating community proportion based on abundance, representing 64.73% of all depths recorded. A total biomass differed significantly between sites. Pomacentridae has the highest biomass in both deep and shallow waters. The Shannon Diversity Index of Free Fish Community was 2.61, indicating a moderate reef fish diversity. For the phytoplankton, 23 genera were recorded, and the results revealed that cyanobacteria were dominant in the two stations, with 11,064.46 cells per liter in Station 1 and 39,034.46 cells per liter in Station 2, equating to a total of 68.70% and 82.34% composition, respectively. The mean overall density of the different phytoplankton genera in Citulina was 63,517.62 cells per liter. The two stations in Citulina have an overall abundance of 33,000 cells per milliliter, with Auxiliatoria as the representative having 20,650 cells per ml, with a relative density of 62.58%. Results also show that the diversity in Station 2 was slightly higher as compared to Station 1, but Linao has an overall diversity of 1.301, implying that phytoplankton community was of very low diversity. Moving on to zooplankton, there was 6 phylum found from both sites and with over 9 groups. The family Calanidae, Sagittaridae, and Oikopluridae is found to be top 3 most abundant in regards to the number of individuals. A predominance of copepods, which accounted for 68% or 212 of the total groups, were detected, and of which 181 individuals were from the calanoid family. Calanoid was the most abundant category of copepods at both the first and second stations. The values obtained for the Shannon-Wiener index varied from station 1 to a maximum in station 2. According to the criteria of Citorus in 2009, the community conditions correspond to the category of medium variety and medium to low stability, and the community has a very low dominance and species richness. A total of 26 drogue deployments in the host stations from flooding tide for the sea surface current were established, with an approximate total duration of sea surface current sampling during the flooding tide was 2.2 to 3 hours. Meanwhile, a total of 19 drogue deployments for ebbing tide were established, and the approximate total duration of the sampling during ebbing tide was 2 to 3 hours. Furthermore, flooding tide sea surface currents of Sitio Linao has an average of 17.04 cm per second, which is found in the southern portion beyond the reef slopes, whereas ebbing tide sea surface current has an average of 19.78 cm per second observed beyond the reef slopes in the southern portion, which is the same with the flooding tide. The cross-shore currents and long-shore currents are observed in the area. The longshore current flows southwardly and vital for the distribution of nutrients on the area. The current flow during ebbing and flooding tide may be due to tides, wind direction, underwater topography, and other affecting variables that can alter the sea surface velocity. Let's move on to the focus group discussion. A total of 8 respondents were interviewed during the conduct of the biodiversity assessment in Sitio Linao, Maasim, Sarangani Province. Most of the respondents were mothers, married, and had attained education at the elementary level. The age range of this group is 19 to 59, wherein individuals belong to the same tribe, the Samatausug, and where most of their descendants are followers of the Islam. Villagers in Sitio Linao have built their barong-barong or a small house made of various wood in the coast. When the tide rises, the foundation of their small hut made up of timber are submerged in the water. As Samatausug descendants, these people have acquired their long-standing tradition of building their small huts near the mangrove forests. Despite inhabiting Linao for 3 generations, the paucity of electrical sources and the lack of potable drinking have been making their living conditions difficult. Added to this situation is the insufficient bathroom necessary for hygienic purposes. They would usually go to the mountains to defecate or in a small hole of their huts leading directly to the coasts. The majority of the interviewers were engaged in fishing activities, where the husbands mostly venture out to the sea to fish. Their income source mainly comes from selling fish caught using pukot or fishing nets and mamasol or handline fishing. It appeared that only coastal cleanups, mangrove rehabilitation, and feeding programs were conducted by the government agencies, which were primarily spearheaded by the Department of Environment and Natural Resources and the Philippine National Police. So, So, to summarize, Sitio Linao has a diverse species of marine faunas which potentially contributes to the overall resilience and productivity of the coastal and marine ecosystems. However, potential threats such as neighboring foreshore beach development and coastal pollution could impact the general threshold of its unique habitats. This biodiversity assessment provided supplemental information on the conditions of these biologically significant communities, but future comprehensive assessments in this region should be conducted to allow comparisons and elucidate declining patterns in the threatened ecosystems, helping to craft policies that would mitigate biodiversity loss. In addition, the coastal community residents should be encouraged to participate in the conservation management initiatives of the government by providing sustainable livelihood, education campaigns, and inclusive participation of the residents in government programs. Compounded local government efforts and community participation will most likely make conservation and protection of the remaining natural resources in the coastal ecosystems successful. Now, for the recommendation, the following are recommended that would be useful for the conduct of future assessments. 1. Undergo annual or periodic assessments of the coastal and marine habitats and ecosystems to monitor the changes throughout time. Second, robustly evaluate the habitat conditions of these ecosystems to understand and mitigate the threats impacting it. Third, extensive evaluation of the locals' level of knowledge about the coastal and marine ecosystems of Sitio Linao. Fourth, assess possible dugong foraging in the seagrass meadows of Sitio Linao. Fifth, detailed assessment on the influence of physical and chemical parameters on the diversity and abundance of species in the coastal and marine ecosystems of Sitio Linao. Sixth, promulgate extensive education and livelihood programs for the community settlers in order to make them partners for science and people oriented conservation management. Seventh, establish collaborative efforts among the academe, local government, community settlers, and citizens to create and enforce effective conservation and management of natural resources. And lastly, strengthen the reinforcement of laws and ordinances regarding marine conservation to ensure better protection of the ecosystems present in the area. That's it. Thank you for listening to our presentation.